During the wheat harvest, the weather window is mercilessly tight. Every day that ripe grain remains in the field increases the financial risk, especially if a storm is approaching. The clock ticks fastest right as the day ends. When the sun sets, work traditionally stops, cutting the farm's potential productivity in half exactly when the harvest is most urgent. Farmers often try to push into the night using the combine's built-in headlights. But looking at this photo, the beams wash out against the dense, unharvested crop, failing to reveal what lies more than a few feet ahead. Industrial light towers offer more power, but they are limited by their design. These rigid, stationary masts must be manually dragged into position across dirt. This diagram illustrates the problem, the geometry of shadows. Because a light tower casts its beam from an acute angle on the ground, hitting a massive piece of farm machinery creates an elongated shadow that stretches out directly over the unharvested rows. To safely operate a multi-ton harvester at night, the driver needs a clear view of the cutting header. This requires a light source that removes those deep, angular shadows from the path. The harvest bottleneck is a problem of position rather than raw brightness. Running a safe night shift requires a light source that hangs directly overhead, mimicking the sun. A Washington-based company called Freefly Systems developed a rig to solve this for a different industry, Hollywood film sets. They called it the Flying Sun 1000. The machine mounts 288 LEDs onto a heavy-lift hexacopter. At full output, it projects 300,000 lumens of stadium-grade light from the sky. This chart shows why this design fails in an agricultural setting. While a standard drone might hover for 30 minutes, a rig powering 300,000 lumens plummets to a flight time of just 5 to 10 minutes. A typical night harvest lasts 12 hours. To maintain that light, an operator would have to land the drone and swap batteries hundreds of times per shift, which makes the system impractical for a continuous harvest. Increasing the battery size does not solve the problem. The added weight requires the motors to generate more thrust to stay airborne, which consumes the extra power as quickly as it is added. Engineers in China's Anhui province addressed the battery constraint by removing the battery entirely. This cross-section shows the tethered system. A high-voltage cable connects the aircraft to a ground power station, providing constant electricity to the motors and lights. Because power is constant, it hovers indefinitely at 600 feet, flooding 107,000 square feet of the field with light. The massive LEDs generate significant heat, but the system uses the drone's own mechanics to manage the extreme temperature. The downdraft from the rotors is pushed directly across the LED panels, cooling them enough to run for thousands of hours. Permanently anchoring the drone to a power station removes its ability to roam free. In exchange, the aircraft can perform heavy industrial labor for as long as the generator has fuel. In Fadon County, this technology is already active. Combines are harvesting wheat at midnight, maintaining the same speeds they achieve during the day. The tethered drone repositions in tandem with the harvesters as they cross the field. This allows a farm to double its daily output, ensuring the crop is collected before a storm can destroy it. This setup does introduce new safety risks. Suspending a high-voltage cable over a working metal harvester in the dark is dangerous. If the tether snaps, the aircraft becomes a heavy falling object. Environmental factors also play a role. Unlike a bolted-down steel tower, a drone must fight nighttime winds to stay in position. This consumes more power and can result in a less steady light source for the operators below. The effectiveness of these rigs establishes the drone as a new category of tool, deployable, semi-permanent infrastructure.